This video is for lesson 1-2, more about geometric figures. Learning goals are to describe angles and angle pairs using some more vocabulary words, and also to review the names of parts of circles. First, draw 4 angles with different characteristics, describe each angle, and name them. The 4 general types of angles are acute, obtuse, right, and straight. And so on the screen, I've drawn an acute angle and labeled it with points. Point A, point B is the vertex, and point C on this side, and then put a number inside the angle. This gives me some options of how it can be named. This could be called angle 1. It could also be called angle ABC. And it could be called angle B, using the vertex to name the angle. For the obtuse angle, again, I've put some dots on the sides and written a 2 inside the angle. So naming this could be called angle 2 or angle DEF or angle E. Here's a picture of a right angle. This right angle could be named angle 3 or angle GHI or simply angle H. This little box indicates that this is 90 degrees. Finally, the last type of angle is called a straight angle. It's formed from opposite rays. This could be angle 4, angle JKL, or angle K. Here are the 4 general types of angles. Question 2. Compare and contrast each pair of angles. So last time we looked at 4 angles by themselves and used words acute, obtuse, and so on to describe them. Now let's look at angles in pairs. In this drawing we have angle 1 and angle 2. They share a vertex and they share a side. We can call them adjacent. So here's another vocabulary word about angles. Also, angle 1 is acute and angle 2 is obtuse. Question B, in this figure, angle ADB, that's this one, and angle BDC, that's this one, are adjacent. They share a vertex and the side. Both are acute. Question C, here are 2 angles. These do not share a vertex and side, so they are not adjacent. They are both acute because they measure less than 90 degrees. Question D, these are not adjacent. This one is acute. This one over here is obtuse because it measures more than 90 degrees. Recall that the sum of the measures of complementary angles is 90 degrees. And the sum of the measures of supplementary angles is 180 degrees. So we could have further described the 2 that we had already done. Because these 2 angles sum to 90 degrees, they are complementary. In question D, because 30 plus 150 is 180 degrees, they are supplementary. So we have some vocabulary words to describe angles independently of other angles. We can say that they're acute, obtuse, right, or straight. We also have vocabulary to describe where they are positioned to each other. Sometimes they're adjacent. And we have vocabulary words to describe relationships in their measurements. If they add up to 90, they are complementary. If they add up to 180, then they are supplementary. So next question, question 3. The figure below shows 2 intersecting lines. Name 2 angles that are supplementary to angle 4. To be supplementary, the measures add to 180. So here is angle 4. Are there any angles that you could add to this and make 180 degrees, also called a straight angle? And there are. It could be angle 3 or angle 5. So angle 3, angle 5, and then here's the reasoning. Because when you pair them with angle 4, they form a straight angle. That makes them supplementary. The next one, Here's a lengthy question. Complete the chart by naming all the listed angle types in each figure. In the first column of the chart, we're looking at this figure. In the second column of the chart, we're looking at this figure. Let's tackle the first column. Acute angles, angles that are less than 90 degrees. In this drawing, I think that's angle 8 and angle 9. Obtuse angles, these are angles that are greater than 90 degrees but less than 180. In this drawing, it appears to be angle 7 and angle 10. Angles with the same measure. In this drawing, angle 8 and angle 9 appear to be the same size. There's even a vocabulary word for angles that are created by intersecting lines and they're at opposite positions from each other. Those are called vertical angles. So angle 8 and 9 are equal to each other, and angle 7 and angle 10 are equal to each other. Next is supplementary angles, angles which add up to 180 degrees. In this drawing, if we put 7 and 8 together, that creates this straight line. There are other angles that can be paired together to create straight lines. And so here are the 4 angle pairs that are supplementary. Last, we have complementary angles. Complementary angles add up to 90 degrees. In the first figure, there are no pair of angles that add to 90. The answer is none. Second figure is more complex. It has more rays in it, and also the angles haven't been numbered, so when naming them, we have to use the capital letters. Let's start with acute angles, angles that measure less than 90 degrees. One of them appears to be this. This is ABF. Another angle is in between here, CBD. And then this angle right next to it, DBE. These are all acute angles. Okay, obtuse angles, angles that are greater than 90. We have angle ABD, that's obtuse. Then we have angle F to B to C, that one is obtuse. And last we have angle F to B to E. That angle is obtuse. Angles with the same measure. There are several. In this we have 2 90-degree angles, so angle ABC is equal to angle CBE. Then we have angle ABF equal to angle DBE. Here's ABF right in here, and then its vertical angle, DBE, these are equal to each other. And we have angle ABD and angle FBE. That's this obtuse angle in here, and then the obtuse angle opposite from it. Now, supplementary angles, angles that add to 180. There are 6 pairs of angles that add to 180 degrees, and they are listed here. And finally, complementary angles, angles which add up to 90. There are 2 pairs. The next part of this lesson has to do with circles. So we're changing the pace a little bit from angles. Let's start to think about circles. One vocabulary word is the word chord. A chord is a segment with both endpoints on the circle. Next we have diameter. A diameter is a segment that passes through the center of the circle. And then we have radius, a segment with one endpoint on the circle and the other endpoint is the center of the circle. Question 5, in the circle below, draw and label each geometric term. Start with radius OA. So because it's a radius, it begins at the center. That's point O. And then it's a segment extending to the circle and touching the circle at another point, in this case A. So here in kind of brown ink is the radius OA. Next we have chord BA. Well, we have already found point A, so if we put another dot on the circle and call it B and connect them, there is chord AB. And finally, diameter CA. Start at point A, travel through the center, and then continue on to the other side. There is diameter CA. Question 6. Referring to your drawings above, what is the geometric term for point O? Point O is called the center of the circle. Question 7. The circles below are concentric, meaning they have the same center. The center for both circles is point P, and we see that here. Question A. Construct viable arguments. Explain why circle P is not an appropriate name for the smaller circle. The reason is that there are two different circles that have center P. So if you just named it circle P, we wouldn't know if that referred to this smaller circle or to this larger circle. So question B, what is an alternate name for the smaller circle? How about calling it circle P with radius PQ? By defining the radius, that limits us to this circle. We know for sure we're talking about that circle. Here are some check your understanding questions, so I'll pause the video for you to answer these. In this video, we discussed how to describe angles and angle pairs using some vocabulary terms like acute, or adjacent, or complementary and supplementary. We also identified and named parts of circles using words like center, chord, and diameter.